Um, I'm not the education, but just observation. Culture usually means pattern of behavior.
Means
Patterns of behavior. Some of the routine, right? I mean, people used to do in a particular context. So that means that whenever you introduce a technology, and if a technology allow people to do something they could not do before, and therefore trigger a change of behavior patterns.
yeah.
Right? I think that's what we see. So in terms of the game, and the children in the past, they could not imagine how to change a game. Actually, they can do it because if they play with a paper game, they can still redesign the game to play it easily in a different way. But they could not see the effect easily. They could not imagine how, when they change the game, how the game will look like. But now with this computer game, now they can think about the change of the game and actually see the effect of changing the game. So the technology enabling to do that. So that means it's a productivity game.
Means
Productivity.
yeah.
Because technology usually increase productivities. But with increase of productivity, and actually trigger creativities. Because they can do something more effectively than before. They can do something new they could not do before. Then change the pattern of behavior, therefore the culture. Right?
Yeah, exactly.
Yeah. So I think in terms of answering the question you have, how the digital technology can change. I mean, because technology usually cannot create creativity, can only change productivity of what people do.
Your last point is a little stronger than what you said. You think technology can only change. Hang on, no, we need the microphone. Sorry.
Like you said, I mean, information is not equal to knowledge.
No.
Right. I mean, productivity is not equal to creativity. So technology cannot make people creative, but it can give them the tools to do something more effective than before. Therefore, they could do something new than before. Right? Therefore, they can become more creative than before. Just like the pen. In the ancient time, there's no pen, right? Because they don't have ink, right? Therefore, when they write or learn, it's very slow. But now they have paper and ink and pen. They can do it much faster. Therefore, people can write much creative text than before. Right? So, and just
no, I think it's a really, really good point. And actually, I think the whole history of you can make a whole history of these. You can make a whole history of how technical, cultural innovations, like the pen, have the history of making things doable by people that were undoable before. And they're not always physical things. When the invention of algebra, of an equation, the idea of an equation, which is not that long ago, about 350 years ago, meant that suddenly many, many people could express laws of physics, which previously you needed a Newton to do. And that wasn't a physical, it was a cultural technology. So yeah, I completely agree with you. The other thing is, of course, that when you have a new technology, there's always a time gap before it becomes clear what that technology is good for and how to use it. For example, none of us, even I, am not old enough to remember when film got sound, because originally movies just had pictures and no sound. And when sound was introduced, people were not sure, was the sound... Originally, people only heard sound of speaking when the camera was pointing at the person's face, and then it became clear that you could do other things. You could have people talking off screen, you could have all kinds of other things. So learning how to interpret the new technology was a really important way to come to terms with what that technology was possible for. this is taking a surprisingly long time. I think I'm going to... Oh, let me give an example of, I don't know if it would fit into the heading of productivity. I'm not sure. Let's see. So I'm going to give you an example now. This is where I'm beginning to do things that I wasn't anticipating doing. But I want to give an example of not my research, but some research of some very good colleagues and friends of mine in the United States at Northwestern University. And I, of course, will give anybody who's interested the reference after this workshop. So this is not my research, but I think it's a very interesting development of, under the heading of learning to use a technology for something completely different that we couldn't imagine before. So I need to just launch this piece of software. This is a programming language actually called NetLogo. Barbara, you probably know about this, don't you? And has anybody here, apart from our United States colleague, heard of NetLogo? Okay. So it's a very interesting piece of software, and it allows you to do something that was unthinkable, really unthinkable, 30 or 40 years ago. And then it became thinkable for scientists and mathematicians, and now it's become thinkable and doable for everybody. So it's a really great example. It's like your example of writing. First it wasn't possible, well, it was possible to write. You had to take, I don't know, you had to chisel bits of rock or something. Then it became possible only for the elite, and then it became possible for everybody. So it's a real structural change. And what this software does is it exploits the following idea that is now become completely accepted, but wasn't accepted some time ago, a few years ago, which is that many, many interesting phenomena in the world emerge from the interaction of individuals doing each his or her own thing, people or molecules, doesn't matter what, doing their own thing, and out of the interaction between hundreds, thousands, sometimes millions or billions of these individual reactions taking place, a global change happens. Something happens on a global scale. So it's a question of local and global scale. Now actually, we all have experience of this every day. You take a coin, you flip it, you do it 6 times, and really, if I said to you, would you be surprised if there were 6 heads and no tails, you would say, well, yeah, I'd be a little bit surprised, but it's not that unusual. You'd say probably 3 and 3 would be the most usual, but 4 and 2 would not be that bad, even 5 and 1. And I'm sure if we each did it in this room for 6 times, 2 or 3 people would get 6 heads or 6 tails. But if I said to you, now do it 6 million times, and you got 6 million heads, I think everybody here would have an intuition that something was wrong with the coin. Okay, so we're very, very used to emergent phenomena of a property, of a phenomenon happening, which individuals, the individual coins, know nothing of, but which in long-term behavior emerges. And this piece of software is great for thinking, all right, what kind of phenomena could we possibly model? And I'll just share with you, I should give the name of the person who runs the team of researchers who developed this particular version of this software is Uri Walensky. And as I said, I'm very happy to give people his... Actually, if you Google NetLogo, one word, you'll find him and his team and all sorts of other... And you'll also be able to download the software.